So we talked about clinical trials and how they're done and why they're so expensive. And now we're going to talk about an alternative to clinical trial that is called observational studies. Okay, so random clinical trials belong to this class called randomized studies, which is the case when you control the input, control which patients take medicine and which don't, and then you observe the output. And then if you see statistically significant dependence, then you know that then you've proven that there is a causal effect. So randomized trials are the gold standard for establishing causal relationship. However, in many cases, it is impossible or too expensive to do these randomized trials. So here are some examples. Let's say that we want to know the effect of diet on health. So how sugar intake affects health. So we want to do that on people that are living their regular life. We can't really control their sugar intake, so we can only observe a correlation, and it's hard to see a causation. Similarly, the effect of decreasing taxes on the growth of the economy. So there's very strong opinions this way or the other, whether this effect exists, but it's very hard to do a controlled experiment, have a separate United States in which we increase taxes and another one in which we decrease taxes. And another very common one is the long-term effects of drugs, right? So drugs are tested in a clinical trial in hospital setup, which is very specific, and the question is, when people take these same drugs in their day-to-day life, do they have the same desired effect? Okay, so here is an example of an observational study to compare the long-term effectiveness of approved blood pressure drugs. Okay, so there are many blood pressure drugs, and here I'm just listing the main categories of types of blood pressure drugs. For each category, there are many specific drugs and companies that are making them. So this list is actually much longer if you consider all of the drugs that are on the market. So how can we possibly see which of these drugs is more effective? So one way to approach it is to collect data that is already being collected. So let's say data from drugstores can tell us for people which drug they're taking. And data from the healthcare provider, the doctor or so on, can tell us how the drug is having an effect. So what is the blood pressure over time of that patient? So if we could connect these two things together, we could compare the effect of different drugs, right? We could see which drugs have a bigger effect and which have a smaller effect. Now, clinical trials are superior because there the bias is controlled. So we have a control over all of the aspects of the life of the patients, and so we are not allowing other spurious effects to come in. On the other hand, it is very hard to have more than 100 patients because doing so is so expensive. So this causes a large variance. So we have estimates that are unbiased, but they have very large variance. On the other hand, in observation studies, we cannot show causation, and there is a danger of large bias. On the other hand, we can collect many more records, so it's not unlikely that we can collect at least 100,000 patient records about blood pressure. And that means that the variance would be small. So the bias itself can be reduced by various methods for correcting. Okay, so you can group the patients by age, gender, race, and so on, and basically see what is the effect on that specific group, and therefore not be sensitive to the fact that this drug is taken mostly by women, let's say. And you subtract the effect of these nuisance variables, like, let's say, gender. So this is something that is growing now and becoming more and more looked at now that we have big data and we can collect actually enormous amounts of information. But of course, there are other issues that are important in this case. One is patient's privacy, right? So those records that CVS collects on you and your doctor collects on you, are you really willing to have them correlate the two so that they can study which drugs are better, even though this might reveal information about you that you don't want some people to know? And of course, there places that generate these data, like big pharma and big hospitals, have their own commercial interests, which might cause their own type of bias into these studies. Okay, so randomized studies are still the golden standard, but observational studies and various other combinations are becoming more and more important. So to summarize this section this week, I want to go through a few of the main concepts in hypothesis testing. And these are the concepts that you should make sure that you understand so that you are ready for the exam. So the first is correlation does not imply causation, right? We talked quite a lot about that. The second is the null versus the alternative hypothesis. So we always represent what we believe right now as the null hypothesis, and the alternative hypothesis is something that we're trying to prove against the null hypothesis. We're trying to reject the null hypothesis. P-value evaluates the amount of evidence that we have for rejecting the null hypothesis for a particular sample. It's a random variable. And alpha value is simply a threshold that we put that we require the p-value to be below in order to declare the test successful and the null hypothesis rejected. Okay, so the alpha value is not a random variable. Hypothesis tests, we talked about them quite a lot. There are many, many of them. Basically, they vary in terms of the assumptions they make, in terms of the null versus the alternative hypothesis. In general, the more assumptions you make, the smaller the number of examples you need in order to reject the null hypothesis. The less assumptions you make, the more data you need in order to make this rejection. Randomized trials we talked about. Those are the clinical trials where we control for everything, and so we can measure causal relationship. And observational trials, which are the ones in which we don't really control the variables, but we try to draw some conclusions nevertheless. So that's it for this week. Bye.